Right. This is assignment number 3 of structure of atom. Calculate wave number of the radiation whose frequency is 3 into 10 to the power 18 second inverse. We have to calculate wave number, and wave number is 1 by lambda. See, E is equal to hc by lambda, and also E is equal to h nu. Or I can say 1 by lambda. 1 by lambda is what? Wave number. That will be equal to nu by C. We know the value of frequency, that is given 3 into 10 to the power 18, and we know the velocity of light. Divide and you'll get the answer. Second, how many photons of wavelength 4000 angstrom would carry 1 joule of energy? We'll calculate the energy of one photon and then divide total energy. That is 1 joule of energy is the total energy. We divide 1 joule by energy of one photon. Now, energy of one photon. Energy of photon will be hc by lambda. We know the value of h, we know the value of c, both are constants, and wavelength is given 4000 angstrom. This is 4000 into 10 to the power minus 10 meter. Substitute all the three values and calculate. Energy of one photon will come out to 4.96875 into 10 to the power minus 19 joule. So energy of photon will be this much. Now divide 1 joule by the energy of one photon. That will be the total number of photons which will carry 1 joule of energy. So number of photons will be 1 divided by this value. You'll get the answer. Third, calculate the frequency in kilohertz of the radiation whose wavelength is 2.19 into 10 to the power 4 centimeter. We have to calculate frequency. C is equal to nu lambda. Calculate the frequency. Okay. And this is hc by lambda. Calculate the frequency in kilohertz, and we are given wavelength. So this is not to be used. This we want to calculate. This will be equal to c by lambda. C is constant. Value of wavelength of radiation is given. Divide and you'll get the answer. But units should be proper. That you have to keep in mind. Next, calculate the energy of photon whose wavelength is this much. If wavelength is given, energy will be E is equal to hc by lambda. Substitute values, multiply, divide, you'll get the answer. Second part, if frequency is this much. In case we are given frequency, then multiply by Planck's constant, you'll get the answer. It's just multiplication, nothing else. Next, calculate wavelength in angstrom associated with a photon of energy 4 electron volt. Given that 1 electron volt is 1.6 into 10 to the power minus 19 joule. Energy of photon. It is 4 electron volt. 4 into 1.6 into 10 to the power minus 19. So 4 electron volt is this much energy. Now we have to calculate the wavelength of radiation. E is equal to hc by lambda. This is the value of E. H and C are constants. We know their values. Lambda can be calculated. This will be our answer. Again, I'll repeat, use values in proper units. That is something very important. Otherwise, there is no difficulty in these questions at all. Coming to next. Energy required to melt ice. This is a very popular numerical. Energy required to melt ice is 0.333 joule per milligram. Calculate the number of photons of frequency this much required to melt 1 mole of ice. Total energy required. 1 mole of ice. Ice is nothing but water. And 1 mole of water will be 18 grams of water. So we have to first find out how much is the total energy required to melt 18 grams of water, that is 18 grams of ice. We are given 0.333 joule is the energy required to melt 1 milligram of ice. So this is 0.333 joule for 1 milligram into 1000. This is the energy required to melt 1 gram into 18. This is the total energy required to melt 1 mole, that is 18 grams of ice. When you calculate, this will come out to 5994 joules. Now we have to calculate number of photons of frequency this much required to melt 1 mole of ice. Now, E is equal to N into H nu. We are given the frequency. Yes, frequency is given. H is Planck's constant. Number of photons we have to calculate. Total energy is this much. So this N will be the answer. Total number of photons. Next. Next two numericals are again very important ones. Nitrogen laser produces a radiation of wavelength 1.2 nanometer. If the number of photons emitted is 5.5 into 10 to the 24, calculate the power of laser. Now here the hint is given that power is nothing but total energy. And you know, total energy will be energy of one photon multiplied by total number of photons. So what you have to do is calculate the energy of one photon and multiply it by number of photons. So it will be power is equal to total energy of laser. And this will be N into, we are given wavelength, N into Hc by lambda. N is number of photons emitted. This is 5.5 into 10 to the 24. H and C, we know. Lambda is given. This is 331.2 nanometer. 331.2 into 10 to the minus 9. Numerator is H and C. Both are constants. You know their values. Just multiply and divide. You'll get total energy, that is power of laser. Next. Signals obtained from distant stars are very weak. If a photon detector receives a total of 3.31 into 10 to the minus 18 joules of energy from the radiation of 600 nanometer, calculate number of photons received by the detector. Now, in this case, total energy of the radiation will be, we'll again use the formula E is equal to N into Hc by lambda. Right? We have to calculate number of photons. We have to calculate value of N. H and C both are given, both are known values, they are constants. And radiation of 600 nanometer, it means wavelength of radiation is 600 nanometers. This will be 600 into 10 to the power minus 9 meters. Energy is given 3.31 into 10 to the power minus 18. So we know the value of E, H, C, and lambda. Calculate number of photons, that will be the answer. Next, a 60-watt bulb. At the end of the question, you are given what is the meaning of 60-watt bulb or 100-watt bulb. If we say 60-watt bulb means it will emit 60 joules of energy in 1 second. So the value of energy is 60 joules, you can say. A 60-watt bulb emits radiation of 828 nanometer. Calculate the number of photons emitted by it per second. Again, the same formula. E is equal to N into Hc by lambda. Energy 60, because this is 60-watt bulb, 60 joules. Number of photons we have to calculate. H and C constants, we know their values. And wavelength of radiation is 828 nanometers. This will be number of photons. That's all. There's only one theoretical question to be explained. In Rutherford's experiment, if aluminum foil is used in place of gold foil, what difference will it will be observed? This is a very important question. See, if we use aluminum foil in place of gold foil, then what will be the difference? See, atomic weight and atomic number of gold are much higher than aluminum. It means nucleus of gold is much heavier than the nucleus of aluminum. So when aluminum foil is bombarded with alpha particles, then number one, number of particles, alpha particles, which will pass through it, that will be less because size of the atom is smaller. Number two, angle of deviation will be less because positive charge on the nucleus is smaller compared to the positive charge on the nucleus of gold foil. So I'll repeat, two differences will be number of particles which will pass through gold foil will be less, and angle of deviation of alpha particles will be smaller because positive repulsion will be less.